So let's try one like number 21G. You're to evaluate these definite integrals by interpreting the function and the value geometrically. In other words, you'll need to essentially know what the graph of the function looks like, and then from that use basic geometric formulas like the area for a square, rectangle, triangle, circle, whatever, to find the value of the definite integral. Okay, so what exactly does the graph of the square root of 49 minus x squared look like? Well, I do this in the lecture video, but we'll do that here again. If I let y be the square root of 49 minus x squared, if I square both sides of this equation, what happens? I get y squared equals the squaring of the square root just gets rid of the square root, 49 minus x squared. If I add x squared to both sides of the equation, I get to this form right here, which you should recognize as the equation of a circle. So you probably might need to review equation of a circle. In general, here's the standard form for the equation of a circle. Basically comes just from really the Pythagorean theorem, this equation right here. Yeah, so this formula, the h and k, what the heck are those things? That's the coordinates of the center of the circle. So you have if you have x minus 2 and then y minus 1, then the center would be at 2 comma 1. And then over here you got r squared. R is the radius. So if you look at this, 49 of course is 7 squared, so that tells me the radius is 7. What about the center of the circle? Well, it's x. Where's the h and k? Well, it's x minus 0, right? X minus 0 is x minus 0 squared. So 0 is the h coordinate of the center, and y minus 0 is the k value, right? The y coordinate of the center. So 0 comma 0. So this is an equation of a circle centered at the origin, right? X squared plus y squared equals that. So this is a circle of radius 7, right? Centered at the origin. However, when we go back to the original, we're only looking at y equal what? Positive, right? This value is always a positive value. So we're only looking at the top half of the circle, top part of the circle. And so when I graph the circle here, I've sort of outlined it in red. Here's the big circle, right? This is the circle of radius 7, centered at the origin. So the distance at any point to the circle is 7 units. But remember evaluating the integral from 0 to 7, right? From 0 to 7. So here's x equals 0, here's x equals 7. So just this portion here is what we're looking at, right? And so interpreting this integral in terms of areas, this is 1/4 of a circle. So it's 1/4 times the area of a circle of radius 7 is pi times 7 squared, which of course is 49. So I get 49/4 times pi. And there is the value of your definite integral. I'm going to do one like 21H as well. I'm just going to modify the one I just did. Right, here's the one we just did. I'm just going to change the integral now, same limits of integrations, to 6 plus the square root of 49 minus x squared. Okay, one way of doing this is just let y be the whole thing again, and then do the same thing, except I first have to subtract 6, right, from both sides before I square, right? So subtract 6 from both sides, and then squaring gives me y minus 6 quantity squared equaling this. Add the x squared over, and now this is the equation of a circle. This time, notice the center, it's x minus 0, so the x coordinate of the center is 0, but y minus 6, remember that was the k part here in this, that's going to give me the y coordinate of the center. So the center is going to be at 0 comma 6. And again, the radius is still 7. Again, I'm only getting the top part of the circle because this value for y is always a positive quantity, right? It's the top part of the circle. So if I graph the circle whose center is at 0 comma 6 right there, and the radius is 7. So if I go down 7, that's going to bring me down to -1, right? 6 minus 7 is -1. If I add 7 going up, that's going to bring me to 0 comma 13. If I go 7 to the right, I'll be at the point 7 comma 6. If I move 7 to the left, I'll be at negative 7 comma 6. So there's my circle. All these points are fixed distance. But remember, the integral is going from what? From 0 to 7. So from 0 to 7, here's the only portion that we're talking about, right? And so I'm integrating this portion from 0 to 7. So what I have is from 0 and 7, I have two regions here. I have this region here, which is a quarter circle, and then this region here, right, which is a square, right? So the top part, 1, is a quarter circle. So that's 1/4 times the area of this circle, which is pi. The radius, remember, is 7 squared, right? And then plus region 2, which is just a square. And what's sorry, it's not a square. Excuse me, it's not a square. It's a rectangle. I said square, but it's a rectangle, right? Because the base is 7 units, notice, going from 0 to 7. This goes up to this line right here, which is at a height of 6, right? So this is a 6 by 7, a 6 by 7 rectangle. So the area is just the length times the width. 7 times 6 or 6 times 7. So here I get 49/4 pi, like we got the last time, plus 6 times 7 is 42. And, if you want to go ahead and combine this as one fraction, you can, but this is sufficient. You can approximate this with your calculator if you need to, but that is the value of the definite integral in this case. Notice we're not using what you'll be learning about later, the fundamental theorem of calculus. Some of you have had calculus 2 before. And so we're not using that. We're just interpreting this right now in terms of geometry, basically, right? What's the area of the region under this curve, above the x-axis, but under this curve? Well, it's this quarter circle plus this rectangular region. Hope this helps clarify a little bit on some of these.